Okay, we're going to talk about functions, but we're going to talk to them as equations. So we have an equation here. This is a function. And we also have function notation we'll talk about as well. There are two parts of a function. There's the x and y variables. The x variable is the independent because it can be any number. And then y is the dependent because it depends on what x is. So it changes based off of what x is. So we pick x and then we get an answer, which is y. So one is independent, one is dependent. Now, the notation we often use to represent the y value is f of x or f at x. And that is called function notation. What it doesn't mean, I want to go down here to this great question, is f of x does not mean take f and multiply by y. So I'm going to highlight that because this is what common mistake, but this is a notation that we use to represent y. So right here, this is just another version of y. Now, we're going to use function notation to solve our equations. So all that means is we're going to take whatever is in this notation and replace it where we see the x in the equation. That's all notation means. So I'm going to take f of 4, means I'm going to substitute it for the x in the equation. This does not get multiplied or changed. It's just f of 4. And when I do my math, this ends up being 11. So what we're saying is this is the x, this is now the y. And so we can pick any number for x, that's why it's independent. And we get a value which is dependent on the x. So there's how we use function notation. So let's do that again. Here we have g of negative 2. So what that means is I have g of negative 2 equals, and I'm going to take 2, and I'm going to substitute the negative 2 in where x is, wherever x is. So in this case, g of negative 2, if I do my exponents first, I get 4 times 2, which is 8 minus 1. So g of negative 2 is 7. So this being my x, and my answer, since y, is the 7. And I could write this in ordered form if I wanted to, as such, just like I go back over here and do the same thing here. This could be a 4, 11. So if you're given an ordered pair, you can use it to substitute into a function, or you can give it a notation. So what we're going to look at is a table that represents function notation, and you can see the function notation right here. The first question, explain why this table defines a function. And that is because the x values are different. And if you look at them, every one of them is different. So there's your A. The next one is find the domain and range. So our domain are the x values. So my domain, negative 2, negative 1, 0, 1, and 2. And then we want to find our range. So our range is simply the 5, the 0, the 3, the 1, and also the 4. So there's A, B, and C, or A and B. So the next one is C. So we want to do our substitution. So to do this, we're going to substitute negative 1. Well, if you look at it, negative 1, there's our x value. What do we get for an answer? And the answer is a 0. And if you look at the f of 0, and I'll do that one in red, f of 0, we get 3. So there is the answer right in the table. And then the last one is, what if the answer is 4? So now I'm going to look at this one, and the answer is 4. What is x? And x happens to be 2.